Hey guys, welcome back to my calculus series. Today is my second lesson, I guess, and we're going to talk about solving for limits algebraically versus graphically, as we did in the last lesson. So if you remember from our last lesson, we talked about limits, and limits are quite simply the y value that we get as our x value approaches some constant number. So instead of solving using graphs like we did last time, this time we're going to use algebra. It's generally easier and faster than solving graphically because you don't have to draw out a graph. And in most cases, all you have to do is just plug in the value and you find your answer. As you can see here, it says the limit as x approaches c of a function is just f of c. So basically you're evaluating the function for the value that you are approaching. Alright, let's move on to our first example. Find the limit as x approaches 2 of 3x squared. So let's follow our rules. We plug 2 in to the function, so f of 2 is equal to 3 times 2 squared. 2 squared is 4, and 3 times 4 is equal to 12. So we get a final answer of 12 for that limit. Basic algebra, not a lot of tricks involved. For our second example, it's basically the same thing. Limit as x approaches 3, so we solve for f of 3. And that equals 4 times 3 plus 4. 4 times 3, of course, is 12 plus 4. We get a final answer of 16. Simple enough. Basic algebra. Now, in most cases, that's all you're going to have to do to find the limit. But sometimes it won't quite work out so well. Occasionally, you're going to get thrown problems where you get an answer of 0 over 0. And that basically means you need to mess with the function. And generally when I say mess with it, there means you have to do some type of trick. You have to use algebra to get things to cancel. You have to factor. You have to do things like that until you can get rid of the 0 in the denominator, which leaves you with a solid answer. So let's see what an example here. The limit as x approaches 3. And now let's try to solve it the way we solved the other ones. So that would just be 3 squared minus 9 over 3 minus 3. 3 squared is obviously 9. 9 minus 9 is 0. 3 minus 3 is 0. We get 0 over 0. So what do we have to do? Well, the numerator can clearly be factored. So x squared minus 9. What is that? We factor that. We get x plus 3, x minus 3. And that's equal to x squared minus 9. Our denominator is still x minus 3. So we can cancel this out. X minus 3's cancel. And then we get an answer of x plus 3. Well, that's not our answer, but that's what it cancels out to be. And finally we plug in our 3. 3 plus 3 equals 6, which is our final answer. Alright, in our last example here, we're going to use something known as a conjugate. You should remember that from algebra. And basically all you do, well, like the last time, 4 minus 4 would be our numerator, that's 0, and square root of 4 would be 2. 2 minus 2 is 0, so again we would get 0 over 0. So we have to mess with it. So we can leave our numerator the same, denominator the same. And I put a hint here, we just need to use conjugates. So we multiply by the conjugate of root x minus 2, which is of course root x plus 2. And we have to multiply the top and the bottom by root x plus 2. We do this because, well, root x plus 2 over root x plus 2, well, that's simply 1. And we're allowed to do that because we're not actually messing with the original equation. All we're doing is multiplying by 1. I'm not sure why not. There we go. Alright, and we want to try to get things in the numerator to cancel. So we're going to actually leave the numerator the same and we're only going to multiply out the denominator. So what do we have? Root x times root x, that is just x. And then we have plus 2 root x and minus 2 root x, so that's just going to cancel out to be 0. And finally we have minus 4, because negative 2 times positive 2 is equal to 4. Alright, so our denominator remains x minus 4 times root x plus 2. As we multiply those together, the x minus 4's cancel out from the numerator and the denominator, which leaves us with root x plus 2. So now it's simply a matter of plugging our constant back in and solving for the function. So f of 4 is equal to square root of 4 plus 2, which obviously is 2 plus 2, which equals 4. So our final answer here is 4. And now that basically concludes this lesson. So far, this seems like a boring waste of time. It's been basic algebra, basic graphing skills. We haven't really done much with limits so far, but you'll see they're actually important in the future. Once we get a couple more lessons in, we're going to use something known as derivatives to find slopes of lines, of curves, of functions, of whatever. So just hang in till then, and this is all going to make sense soon. Alright, thanks.